Welcome to Knowledge Share channel. In this video, we will be discussing about that is moving iron instruments. Moving iron instruments are also, in short, it is called as MI instruments. So here from this topic itself, you can see moving iron. I have written as moving iron in blue color and again MI in red color. So so now onwards, I will be instead of moving iron, I will be telling as moving MI. Okay, MI. MI is nothing but the moving iron. Yes, you all know in previous video we have discussed about the basics of instrumentation. So all the instruments, that is analog instruments. So here we are discussing about the analog instruments. So if you are not watched the previous video, you can just watch it and come back so that it will be easy for you to have a better understanding of this particular video. So MI instruments is what we are going to discuss. So before going into that, we will just see how it has been classified. Okay, how any instruments, any analog instruments can be classified, broadly classified into two types. One is the MI instruments, which is called as moving iron instruments, which is called as moving iron, and the other one is moving coil, that is MC instruments, moving coil. See, for example, what is iron and what is coil? So iron is nothing but if you have an iron core, then that is called as iron, and if it is moving, it is called as moving iron. If the iron core is moving, which is used to measure a particular quantity, then that is called as a moving iron. If a coil is moving, and because of which this pointer attached to this coil is also moving, and which is showing the reading, then that type of instrument is called as a moving coil. And in short, it is called as PMMC. See, here I have given as PMMC for the moving coil. Why it is called as PMMC is because in moving coil instrument, we have to use permanent magnet. We have to use permanent magnet. Only with the permanent magnet, the moving coil instruments will work. So, and because of which I have, it is also called as permanent magnet moving coil. So, anyway, in about the MC instruments, we will put a separate video. In the next upcoming videos, we will be discussing about the MC instruments. So, which is nothing but PMMC, that is permanent magnet moving coil. So, now in this video, we will be discussing only about the first topic. Okay. So, we will be discussing about the first topic, that is moving iron instruments. Okay, moving MI instruments, that is moving iron instruments. Okay, so in this an iron core will be there, and that iron core will be moving or deflecting according to the magnitude of the current. Okay, if the magnitude of current is high, then the iron, that is the cylindrical iron, will be moving, deflecting to a large value. If the magnitude of current is less, then that iron will be deflecting a very low value, and because of which the pointer settles down at a low value. So that's why it is called as moving iron. Okay, moving iron core. Okay, that is called as moving iron. In short, is called as MI instruments. Okay, so this particular instruments, we will just move on. Okay, this particular instruments, okay, are classified into two. Basically, it is classified into two different types. One is the attraction type. Okay, attraction type. So if it is getting attracted, and because of which a force is produced, that is called as attraction type. And if it is getting repelled, repulsion means again there are two magnetic force which is getting repelled, and because of which a force is produced, and that force is used to make the pointer to deflect on the scale, that is called as repulsion type. Okay, so the basic analog instruments is of two types. One is the MI instruments, the other one is the MC instruments. MC instrument is also called as the PMMC instrument. In this video, we are going to discuss only about the MI instruments. MI instruments are classified into two types. One is called as the attraction type, the other one is called as the repulsion type. Okay. So, based on the whether the forces are attracting and producing the force, then that is called as attraction type. If the forces are getting repelled and producing a counter force, then that is called as the repulsion type. Okay. So, now we will go on to the topic. Okay. So, I just want to convey here that moving iron instrument is the most commonly used lab instrument. Most of them, even when you are compared to your PMMC, that is your MC instruments, MI instruments are most frequently used. For example, if you have 10 numbers of instruments in your lab, in that I am sure 7 instruments will be of MI instruments and only 3 instruments will be of MC instruments. So, why it is so? By the end of the video, you will come to know why it is. Okay. Anyway, From this 70% of the instruments we use is MI instruments, only 30% is MC instruments. Okay. So, in which particular type of application we can use MI instruments and which type of application we can use MC instruments is what the discussion is all about in this video. So, before going into the MI instruments, I just want to convey that what are the advantages of this. The main advantage is it is having low cost, it is having high accuracy. Okay, it is having low cost and it is having high accuracy. Okay. So, this is the main thing which makes this moving ion instruments to have more more percentage of the instruments when compared to MC. Okay. So, it is very less costly when compared to MC. Okay, MI instruments are very less costly when compared to MC, and also it is also giving a reasonable accuracy when compared to MC. Okay, now we will move on with attraction type. So, first is we can discuss about attraction type, then we will discuss about the repulsion type. So, both the types we should be clear. Okay. So, in this how I am planning is, so I will be discussing about both the MI attraction type as well as MI repulsion type. Okay. So, in MI attraction type, first I will be covering how it is being constructed and how it is working. Then I will be going what are the different types. So, if you are not clear with what is deflecting torque, what is controlling torque and what is damping torque, please go to the previous section of my videos, okay, previous video, and you can watch it and come back. Okay. So, what type of deflecting torque is used in MI attraction type, what type of control torque and what type of damping torque is used. And similarly, what are the errors that are produced, what are the errors that are being produced by this MI instruments, and what are the advantages of this in MI instrument, and there are some disadvantages also in this MI instruments which we are going to discuss in this all about. Okay. Similarly, then we will come to the MI repulsion type, and again we will be going and discussing about the construction, working, deflecting torque, control torque, and what is the damping torque, and what are the error involved, and all those things we will be discussing. Okay. So, let us go into the topic. So, first we will be discussing about the MI attraction type. So, first we will be discussing about the MI attraction type. Okay. Then we will discuss about the MI repulsion type. So, MI attraction type is what first we are going to discuss. Okay. Okay. So, this is the basic diagram of a MI, that is attraction type. So, this I am marking it as in violet color. So, this is what it looks like. An MI attraction type meter will look like this. Whereas, I will mark this in green, whereas the MI repulsion type, okay, that is repulsion type will be looking like this. In most of the cases, the attraction type is used much when compared to the repulsion type. Okay. This one which I marked in green is called as a repulsion type. So, it is having a different construction when compared to the attraction type. Okay. So, here you can see that this is the MI, that is moving ion attraction instrument, and this is the radial vane repulsion type. Okay. Anyway, this repulsion type instrument are again classified into two different types. Okay. So, here we will be discussing only about the radial vane type. Okay. Radial vane type. So, let us go into the discussion one by one. So, first we will discuss about the moving ion attraction type instrument, which is in violet color, and then we will go on with the radial vane repulsion type instrument, which is in green color. Okay. So, let us go into one by one. Okay. So, this is how it looks like. Okay. So, there will be a big black box will be there, which will be covering. So, if you just open the black box and if you just open the screws and nuts and everything, inside you will be having something like this. Okay. All your MI instruments will look something like this. Is it okay? It will be looking something like this. So, how it works? Okay. So, how it works? So, here we will be discussing about its construction, then we will be discussing about its working, and then we will be discussing about what are the different types of torques, how it is produced, and in final conclusion we will be discussing about the other advantages and disadvantages. So, let us go into the MI attraction type construction. So, in MI attraction type you will be having a flat coil. You can see that there is a flat coil is there. Okay. So, here you can see that a flat coil is there. So, this is the flat coil. Okay. So, here this is the flat coil. I will just mark it in green. So, this is a flat, okay, it is flat, it is not shown because something. So, here also you will be having a flat coil, some flat coil is there. So, this is the coil, okay, some coil is there, and it is having some flat disc. See, here you can see that, see this disc is the most important one. So, I will just mark it here, this disc. This disc is called as a moving iron. So, this is being connected to the pointer, and this moving iron is going to rotate. It is elliptical in shape. You can see that this moving iron is an elliptical in shape. Okay. So, whenever there is an ion, it will be attracted to the magnetic field. So, that is why they are using iron. It is not a magnet, it is an ion, and it is left to freely rotate. So, it is attached to the spindle. Okay. So, this is the top view of this particular MI instrument. So, this is the top view, okay, that is from top you are seeing this, okay. So, it is this particular pointer and this particular moving iron is being attached to a spindle. Spindle is nothing but which is vertical, it is vertical in there, okay. So, it is at this center point, I will just mark it here, okay, it is center here, okay, and this moving iron and this particular pointer both are attached to that particular spindle, and both are allowed to move over the scale. So, here you can see that this is the scale, okay, and this is the scale, and in this scale the point will be moving and it will be deflecting and it will be showing the reading. Is it okay? So, construction wise, okay, so actually it is also having a spring, okay, it is also having a spring. You can just see here it is having a spring. In for example, but in this side view, if you see in the side view, it will be having a spring. That spring will be producing the control torque, okay. Whereas the magnitude of current that is flowing in this coil, okay, this coil is there, no, this magnitude of current. So, this is the coil winding. So, the magnitude of current which is flowing in this coil, so this coil, magnitude of current that is flowing in the coil will produce a deflecting torque, okay, because what happens is, since the iron will be attracted. So, when the current magnitude is very high, the attraction of the moving iron will be very high, and because of which the point will be moving to a larger value. If the current in the coil is very less, then the moving iron will be attracted only very less, and because of which the point of deflection will be of less value. And what is this actually? So, this is nothing but your air friction damping. So, this is nothing but your air friction damping. Why we are using this damping? Because this pointer will be oscillating here and there before settling to a final value. So, if you use an air chamber, okay, this particular pointer, that is the spindle, is attached to that particular piston, and this is an aluminum chamber and it is having a piston, and whenever this particular pointer moves, this piston inside this air chamber will also be moving, and because of which there will be an air friction. So, you can see that the piston produces some air. So, here the air is there, okay, here. So, and because of which what is going to happen is, it will damp the oscillation, because the air is having some friction, and because of which it will damp the oscillation. So, it will always settle to a final value easily, and because of which the life of that particular equipment will be more. So, here you can see that again some control weights are also used. So, these are also used for damping. Okay, so these are all used for damping, W1 and W2, W1 and W3 and W2. So, 3 different balance weight are used. This is used to produce the better damping. What is damping? I have already discussed what is damping, because it will be oscillatory in nature. The pointer will be moving here and there. So, in order to avoid that, this particular weight will always damp the oscillations. Okay, so that is called as damping torque. Is it right? So, 3 types of torque are produced. One is the deflecting torque, because of which the deflecting torque is produced is because of the magnitude of current which is flowing in the coil. So, if the magnitude of current if it is very high, then the deflecting torque will be very high. And what is control torque is produced by the spring. So, spring is not shown because you have to see in the side way, it will be attached to the spindle, and the spring will produce the control torque. Okay. So, so according to the magnitude of the current, the moving iron will be attracted more, and because of which the point will be deflecting to a very high value. So, this is what happens in the moving iron instrument, moving iron attraction type instrument. So, it is the moving iron is getting attracted. So, that is why it is called as attraction type. Okay. So, this is how. So, when the current to be measured flows through the coil, the magnetic field is produced which attracts the moving iron towards it, and because of which the pointer moves, okay, and therefore, the control torque is provided by the springs, and the damping torque is provided by the air friction pointer which settles to a certain point or certain value. So, next we will move on with the working of the repulsion type. So, what do you mean by repulsion type? So, again you are having the same thing. So, here you can see that the pointer is there, okay. So, this is the pointer, And similarly here having a so here you can see that control spring is there. So here you can see that the side view is also there, control spring. This is used to produce the control torque Tc, is it right? Control torque Tc, okay. And similarly here you can see the two different vanes. So how it works is, so it consists of two vanes inside the coil. So one is called as the fixed vane, the other one is called as the movable vane. When the current to be measured flows through the coil, both the vanes gets magnetized, okay, in a similar way, and hence a repulsion force exists between the two vanes. This results in the movement of the moving vane, and thus the movement of pointer is made. Okay, here the current to be measured is always proportional to the movement of the point. So the control torque is provided by the springs. The eddy current damping cannot be used in permanent magnet, because if the permanent magnet is used, it will disturb the magnetic field over there. So that's why the permanent magnet is not used. Okay. So here in this case, you can see that, there are some discussions. So here you can see that, see here the main thing is two vanes are there. So here one is called the moving vane. Okay, this is the moving vane, and the other one is called the fixed vane. Okay, moving vane is there, fixed vane is there. So here you can see that both are with north and south. So here this is also north, here this is also north. Okay, and here bottom is south, here bottom is south, and because of which what is going to happen? Both will get repelled each other. And because of if more current is flowing in the coil, in this fixed coil, if the more current is flowing, then what is going to happen? More repulsion will take place, more repulsion, because both are magnetized in the same way, the same direction. So repulsion will be there, and because of which the pointer will be deflecting high. Okay, so the repulsion type is nothing but you are using a fixed vane and moving vane. The moving vane will be attached to the spindle, again it is attached to the pointer. So the moving vane will be moved according to the level of the current magnitude. So if the current magnitude is very high, then the repulsion force will be very high, and because of which the pointer will be moving at a very large value. If the current in the field coil is very less, then the repulsion force will be very less, and because of which the pointer will be deflecting a very less value. So here the spring is used. So here this is the spring, okay, here this is the spring, and because of the spring the control torque is produced. Okay, so there are three types of torque. So here again the air friction damping is not shown, but anyway here we will be using the air friction damping, whereas in previous case it was shown. So again the air friction damping is used. Okay. So this is a very important concept. So here you can in most of the books they will be saying that the moving iron instrument can be used to both AC and DC. So why? Because but normally it is used for measuring AC, okay, but it can be used for measurement of DC also. But for measurement of DC, they will be preferring the MC instruments, because MC instruments are very are very accurate when compared to MI instrument for DC. Okay, so MI instrument will be used for measurement of AC, whereas MC instrument will be used for measurement of DC. Okay, so why MC instrument cannot be used for measurement of AC is a different story. So here you can see that this theta is nothing but the deflection. So this deflection is proportional to I square. This theta you can see that it is proportional to I square, and so because of which it can be used for AC. Whereas we will be discussing in PMMC in the next video, and we will be observing that the theta will be directly proportional to only I. So hence it cannot be used for measuring the AC values. So only if theta, that is the deflection, is proportional to I square, then negative into negative also will be positive, positive into positive also will be positive. So it can give the positive torque. Okay, so for AC you need something like that. So that's why it is not used for measurement of, that's why this particular can be instrument can be used for. Okay. So what are the errors? Okay, the errors are something like, there are something like in case of MI instrument, hysteresis error will be there. So why this hysteresis error is there is because for small value of current the flux density will be high, whereas for high value of current the flux density will be less. So because of which the that is the pointer will not be uniform. It will be in a non-linear pattern. So you can just identify the, if you are given with both MI and MC instrument, you can easily identify, like if it is having a non-linear scale, then it is called then it will be surely it will be an MI instrument. If you have a linear scale, then it will be surely a MC instrument. So the MI instrument will be having a non-linear scale. Okay, and this MI instrument, since we are using MI, that is moving iron, So it is having lot of stray magnetic field will be there. So if you have any other magnetic field which comes in between, then that will make this moving ion to be weak, because of, so the external magnetic field will be disturbed. So this particular instrument is highly we have to be more precaution towards the external magnetic field. That is one of the main drawback. Okay. So the advantages are, it can be used for both AC and DC, and it is very less cost. It can be used in a very wide range. Okay, very wide range. What is range? That is 0 to 10, 0 to 100, 0 to even 500 is available. Okay, very wide range it can be used. It is highly accurate. But what are the disadvantage? Non-uniform scale is there. Errors like hysteresis errors are there. Then external magnetic field will disturb it. Then for example, this one more small thing is there, that is the frequency calibration. Okay, that is the calibration should be made with respect to the frequency. That is the most important thing in the MI instruments. Calibration should be made with respect to frequency. So the frequency is 50 hertz, then that has to be separately calibrated. If we are using frequency with a higher frequency like 200 or 250 hertz, then the calibration should be of different. So the calibration changes with respect to frequency. So always you cannot use the MI instrument for a particular, it is always specifically designed for a particular frequency. So these are the advantages and disadvantages. Okay, and so really I have given some information related with the MI instruments. So really, if you happy with the knowledge which I have shared, please give a thumbs up. As well, if you have any comments, you can just comment in the box. As well, if you are really interested to share with some other students who are in need of this particular topic, you can just share it. As well, give support to my channel by subscribing it. So thank you all once again. Thank you.